welcome.
Hello, welcome to another episode of Labs Talk.
I'm just done with my stretches.
You're just in time to cover up for the intro. You guys watching us live in the internet, you can see that we're doing a bit of stretching every time the intro is on.
30 seconds of feel-good movements just before the show.
To overcome stage fright, right?
Mm-hmm. All right, perfect. Welcome to another episode of Labs Talk. It's super exciting. We're continuing with our quantum computing series. Great guest today, but before we go there, let's recap the last show.
Absolutely.
Nadim. We talked to Nadim.
Nadim has been the third episode in our series on quantum computing already, and I guess I need to point that out because we touched that so often. Nadim didn't primarily talk about quantum computing. We spoke about a use case where the big hope is quantum computing will improve on that at one point, right?
Yeah.
So
if I remember correctly, the use case that they already solved doesn't really require quantum computing, but there would be ways to make it more and more complex, and then.
Well, it's I understood it's a trade-off. Like the solution that exists today is commercially viable. Like quantum computing may eventually, in the future, solve that better than current solutions. It's about retail sourcing in a nutshell. How you get as a manufacturer, as a brand, how you get your products delivered to your customers, and depending on the size and coverage you have as a brand, geographically, you can put so many factors into the distribution that this becomes a really complex problem, and commercially there's a good solution. They get to a reliable answer within less than a second, and quantum computers, at least for the time being, require more time to boot up these days.
Yeah, it was quite interesting. So, perfect. Should we come to this episode's guest then?
We should, I believe. This is episode number 4, and we are going to move on and talk about standardization and well, before I come up with something, let's just welcome Laure LeBars.
Here we go. Hello,
Here
Laure.
we go.
How are you doing?
Hi, bonjour.
Bonjour.
Very cool. So, Laure, you're researcher, director at SAP, and you also are the president of the QuIC, right? Which is the Quantum Consortium, basically. But I think no one better than you can actually explain it. Can you give us a quick intro to your person, what you've done in the past, and then also maybe just very quickly what is QuIC all about?
Yeah, so me personally, so I'm not a quantum physicist. I'm really a mathematician, software engineer as education. I did my thesis in AI, by the way, in the 80s, and this was on NP problem. So this is exactly the kind of problem that maybe in the future this quantum computing could not solve, but at least do it in a reasonable time, let's say this way. So I got interested in the theory already in the 80s and 90s. I mean, it was just a paper theory. I mean, from the algorithmic point of view, should we have qubits, quantum bits? What could we do with it? But, I did my career running labs, research and development labs in North America, in Hungary, and then I was back in Europe in this SAP research. At some point, I convinced my boss to work on this topic. So it's almost 10 years ago. So I look at that, what exists. So I discovered a brand new community. This was exactly the time in 2016 where there was this conference called Quantum Europe in Netherlands, and this was the kickoff of what we call the European Quantum Technology Flagship, so an initiative from the European Commission. So progressively, I get interest from an algorithmic point of view, what we do in theory, I discovered that, yeah, this was progressing. This was really concrete. It was interesting and kind of challenge for me because, it's counterintuitive at some point. I mean, you have touched it in the previous episode. So at some point, I brainstormed with colleagues, with external partners, universities or IBM, etc. What can we do with that? What does it mean for SAP? How can we, what is it good for us, or does it bring anything in theory in the future? So this is how we progressively started it. This quantum technology flagship started as well, and one of the project is Quantum Internet Alliance, which is really the first blueprint of this future quantum internet. So we are, since 2017, we SAP, not me personally, but the colleagues from SAP research, security research are working on it. And so now we are in phase 2, and that's still running. It's a very interesting project. So progressively, and then in 2020, so this, all the partners in all those projects, and that's all quantum technology. So it's much more than just quantum computing. There is also so sensors and metrology, imaging, communications, simulation, and quantum computing. And in quantum computing, you have the hardware and the software. So of course, sensors and metrology are much more mature technology. I mean, they're in production, they're live, let's say this way. And this, all the partners, all the actors, especially the industry, somehow wanted to go beyond those projects. They said, okay, how to build a community on this. So I started to brainstorm with them, and progressively we came up with the idea to build an association. An industry association. So that was the first lockdown.
And that led to the European Quantum Industry Consortium. This is what you refer to as QuIC, right?
Yeah, exactly. Yeah, sorry, I'm so used to that one. Yeah, exactly. So this is a non-for-profit association, industry mainly, also academic research, RTOs, those research and technology organization in several countries that could be very useful to do this link between the research world and the industry. If we look at, so we started officially beginning of 2021. I was elected the president of this association and running CETAT. If you look at, so we are around 200 members today. Little less than 60% are startups and SMEs. So it's very important for them to be part of this community. 18-20% more or less are large industry like SAP, Airbus, Bosch, etc. I mean, that's it's European wide, so it's EU 27 plus UK, Switzerland, Norway, Iceland, etc. So geographical sense. So that's
so
starting. Sorry.
No worries. So so you said almost 200 members, which is quite a lot actually. So I'm wondering, so what is the key purpose now, right? Of course, you will meet regularly. You will probably work on standardization, if I understand it correctly. But are you also, I mean, there must be some key initiatives, right? The key things that you're driving right now. So maybe you can outline what are the key topics that you're trying to get momentum to basically right now.
So first, and that's officially in the mission of, so it's a non-for-profit association, so it's like pre-competitive environment, etc. But the idea is really to create a community to help globally the competitiveness of Europe in those technologies. Again, it's all technologies. Create an ecosystem. So it could see it as a hub to exchange on different topics, to help each other, of course. If you look, so we are working by, it's really by members for members. We have working groups and expert groups. So working groups are more like transversal. It's about, so you mentioned standardization, that's just one topic, skills, etc. So we are not a standardization body. We collectively sit together and say, what are the needs in standardization? Or we explain to some why the standardization is good and why you need it. So we're not experts in these topics. And we collaborate with those standardization bodies, NLEC on the European level, ISO, or could have different bodies depending on the technology as well. Same for skills, etc. So we are not, the idea is really to collaborate. That's the main, it's really a collaboration.
Maybe one thing, so it's just to bring it back to the last episode, right, with Nadim, we talked a lot about a problem that they had, right? And then actually I remember, Andreas, they had the problem that they first had to define the problem, right? In a more or less quantum readable way, right? So you have to break down your problem into what's the problem, define it in a semantically meaningful way. So is this also part of the, let's say, the standardization or the efforts that you have, basically, that you can try to explain these common problems for, let's say, for software like QuIC or for other hardware around quantum computing, so it actually is feasible to put it into such a computer?
Yeah, I mean, inside QuIC, we are not working directly on the problems. I mean, the algorithm, if you mentioned this, this is the job of every company, and they do differently. And we have competitors, we have different technologies, etc. But yes, this is maybe we can say, okay, what is a qubit? What is a logical qubit? What could be acceptable as a error level, or what is so this is where we this community says, okay, this is what we need, making sure it's not defined by somebody else. But again, the standardization itself is decided in the standardization.
But you do cooperate with those standardization bodies.
We express the needs. We make sure those needs are not penalizing for whatever reason. And also it's a reference for the future production. Again, we have different levels here of maturity in sensing and metrology. This is obviously live, and this is really happening. Where in quantum computing is more difficult to agree on something, but we have to agree now. We don't wait to different computers to exist and then suddenly, we may have to define standards. But again, this is one of the working group. The others, maybe the most important for the members, is what we call the strategic industry roadmap. So it's a collective document. Again, same way, you have different technologies and different aspects, but trying to define what is coming in the next 5 years, 10 years, etc. So giving different horizon. What could be the gaps? What are the needs? Could be the gaps. Talking also about the value chain, because to do a quantum computer, you need plenty of different technologies. So we have these technologies in Europe, somewhere else. What's eventually the risk on those? What are the needs in terms of funding, public funding or private fundings, etc. So that's and this document, it's really by members for members. We publish a subset of it, for the wide community, or in dialogue with the European Commission, for example, to help them to prepare the content of the course. I'm not saying what we say or what we write is dictating the course, or vice versa. I mean, we have different objectives, but trying to find at least they listen to us and they see, okay, that's where it goes to, but sorry, this is our objectives, and here we are here. See also IP is another topic as well. Trade, especially in some of those technology, export control is a big topic. So that's also one other, and the value chain. I mentioned it.
And it sounds like it all sounds like a lot of work and a lot of documents. So
that's a
I'm super
collective.
interested now.
A good 70 pages to read. But again, this everyone with this piece. If you look at the document, someone may say, "Oh, but this technology, there's no information." Yeah, because no members put it. So yeah, okay, that's the idea is not to do a perfect document. The idea is to have something of value and useful for the members. Huh?
Laure, you're also one of our colleagues. Yeah, you work at SAP. So that's why I thought it makes sense to also discuss a bit the importance of quantum computing for SAP, right? For such a company as SAP. So let's chat a bit about that. What do you think will be the impact for SAP, for example?
Yeah, so if I go back, so when we first started to brainstorm, so there is a team now about 10, 12 people. So it's still research, basically. And that's still, but they work. So I mentioned the Quantum Internet Alliance project. So all the security protocols on this future quantum internet are important. But we also work on my first idea on those algorithms, and the example you mentioned is one of those. So generally speaking, everything related to optimization, so machine learning in general, factorization. So of course we can say, okay, future quantum computer could break the how you said security
the crypto,
cryptography
used today. But it's like, okay, we don't do this. We do this because it could. The factorization is typically one problem that can help in those aspects. So let's say it a positive and constructive way. And this is my view on it is that it's not like you're gonna replace everything. Quantum computing, by essence, is good for a certain type of problem. Those problems where it's becoming exponential very quickly. So, but we have another approach. So it's not instantaneous. It's not like quicker, unless there won't be any intellectual challenge. So it's no interest. It's the idea is to have another approach, another way of solving it. Which, by the way, when thinking, we may say, oh, okay, we may apply it on the classical. However, what I want to say is that, especially at SAP, what we do today is, in most cases, pretty sequential. In some cases, those optimization cases, we may say, okay, we need the quantum routine, may be helpful. So we need this mix of classical and quantum. We need this hybrid architecture. This is, for me, the future. Same way, and I think this was mentioned before, we have the CPU and the GPU today. I mean, to do to solve some of the AI processes, we use the GPU, which was not done for that. This was done for graphical. But the way it's programmed. So I hope one day we will have the CPU, GPU, and QPU, where depending of you call one or the other, at some point, the top application developer should be transparent, and conscious of what he's doing, but still, we have to trust whoever is building the computer, so the hardware part, that they will do it. Same way we trust the classical. I mean, you don't care if
and with that broad distribution of required technologies, I would assume that is reflected in the partners you have in QuIC. Like it's not just quantum-focused companies, but all like hardware manufacturers, service providers, anything that
and users
would touch this, and users.
Yeah, and users. We have a lot of those people who are actually future users. Or even if you look at SAP, I mean, we are at the end of the chain. We cannot, we may have one problem, we run it stuff, we have a solution. No, we need something reprogrammable. We need something stable, etc. So that's really the future for us. However, don't wait for the quantum computer to be perfect. We have to think of of it right now. What can we do with it? Also making sure that the future quantum computer will serve our needs, that it's not done for another purpose or so, that at least what we are doing are useful. And this is this team, quantum exploration team at SAP, this is really what they are doing, trying to look at what could be the different topics. And of course, there are plenty of use cases. It's well known on the market. But if you go, each use cases goes back to a mathematical problem, and some they may look completely different, but actually, from a mathematical algorithm point of view, they may be solved in the same way. So this is what we have to look at. Of course, that's
Very cool.
the way to do it. And this team is doing it. I mean, we are not starting from scratch. And again, there will be different baby steps. What can we do today with the actual quantum computer? When I started 10 years ago, they were like 1 qubit, 2 qubits, so it was still a baby step. Today, there are different technologies. Some are, okay, is it superconducting? Is it photonics? Is it ion trap? I don't care. I want qubits. I want this logic in my algorithms. I want a mathematical representation of it, and then I'll use it in my trying to solve my problems. But of course, we have to go through those baby steps. Doing some tries of whatever exists today is noisy or not.
Okay, no, that's awesome, Laure. Allow me that question. We do run this interview with you as part of a series, and we did start that series because we saw a few announcements in the market. We've seen Google announcing a breakthrough. Microsoft had an announcement for their Majorana chip, and even our own employer made statements about quantum computing. Now, you're running this European Quantum Industry Consortium. You have a lot of insight in what is happening. Are you in a position to share the current state of quantum computing? Where are we? What are the recent technology advancements, and how does the market develop as we're speaking for the past couple of months? What is happening commercially, maybe?
Yeah, I don't want to put in favor of one or the other, but no, but that's progressing, and I could see if I look backwards, if I go, the stage it was when I started in it until today. There is something, and contrary to what I could hear 10 years ago, this will never work, or this is too much or is not useful. No, it will be useful for something. And here I will recommend the reading of this paper. There is also, if we look more precisely, because again, the strategic industry roadmap of QuIC is on all technologies, but recently at the request of the director of DG Connect from the EU Commission, we collectively, so it was people from QuIC, but also, and one of our colleagues worked on it, on how will AI benefit from quantum computing, but also how can AI today help to develop this future quantum computing, and there's different aspects. And here there is a paper that was published recently. So it's a very serious paper on research, etc. Sorry, I'm a research person. I'm not or developer at least, but not commercial. But here it explains exactly what's the status, where are we today, what exists or not, what is feasible, and what are the trends, and what are we hoping, where should we work on as well, where should we orient the research, and also, of course, the development. So I think this, I can give the reference if you want, but that's
please.
But this is exactly this when the community sits together. So there was a lot of research people, there was some from industry as well, SAP as well. So it's interesting because it's real stuff. It's not just a commercial announcement, etc. And that's important because we have to make sure that there is not like a big hype. Everybody is hoping that they will solve everything, and then after 2 or 3 years, investors especially say, "Look, we're still waiting for this." No? So, where is the expectation? Say, what can we do or cannot do? And why?
And Laure, it would be great if you could put those references, as that you said, actually into the comments later on. So if you could just drop us these references later on, we'll just make sure they are in the YouTube description then.
Okay.
But the one just very high level question though, actually, is this this feeling that we have? That's basically the reason why we're doing this quantum series, right? Because Christian Klein was talking about quantum computing, and then we saw some developments from Google and from other companies. So is the feeling that we have correct, that it seems to speed up actually, right? And as you said, right, if I understand you correctly, right now you said 10 years ago it might have been an opportunity, right? We didn't really know if it works, but I think today we can kind of see that it works, but it's a question of when will it be commercially available, maybe. Is that feeling correct?
Yeah, there won't be a big bang day. There won't be a day where, okay, suddenly you have a computer and you can do what you want. It's really, really progressive, and there will, in terms of size, etc. We don't have big data on quantum computer right now, so it's not. And again, it's a different approach. So, and those announcements that you mentioned, it shows that there are progress. We are mastering more and more. If you go back to what is quantum technology, it's about mastering those particles at the quantum level. In the 60s, 70s, etc., we could, we produced the laser, the GPS, the DVD reader, etc. They're all quantum technologies, basically. We have sensors, we have metrology, everything is based on those. When we talk about qubit, it means we master one particle. So if it's a photon, we trap it in a mirror and we control its state. We put it in the value we want. And the progress will have been made, and not just the last 10 years, basically, but even before that, is having mastering more and more, having those qubits interacting, making operation on it, etc. So everything that we wanted in theory is now happening. So it's really progressive, and it's not again, there won't be a big day. So of course there is a competition between the IBM, the Google, and you mentioned, and there are plenty of startups, by the way, in Europe, everywhere, are doing something, and that's. Will they merge? Will they be absorbed? Will they disappear? We don't know, but that's that's really booming.
And so just sorry, out of interest, I have to ask one question before we come to maybe the last section that Andreas wants to go to. But isn't it massively expensive to experiment with quantum physics? So is there a place? Is there a big role for startups, really, as you mentioned? Because I heard you have to cool down the systems and stuff like that, but is this something where startups, not just big corps, can actually play a role?
I mean, you have to cool down if you use superconducting qubits. If you use photonics, it's okay. So it depends on the technologies. And there are pro and cons on all. And again, I'm not a quantum physicist, so I'm not the one who can judge. But no, I mean, of course, those startups are. In most cases, spin-off, etc. And when they start, like any startups, they are based on public and or private fundings. They do have an idea. They do have something that works at the research level, and they just go out. So, of course, they may be at the stage, but it's we see. I can mention IQM in Finland. I can mention so Alice and Bob, Pascal in France, etc. So. They're all different technologies. They have different. They are not doing everything, everyone, but they start to be. They sell machines. There are things that are going on this. You have also companies like Multiverse Computing in Spain, who's working on the software side, and they propose something where they combine. AI classical approach and the quantum approach, and they use machine available. So it's not easy for startups, especially this hardware level could be expensive, but they can find funding. They can find. There are also programs on the European level, like your HPC, which is so mainly was initially done so it's a joint undertaking between the EU Commission and 27 plus other countries in Europe, putting money in a pot to build infrastructures. So mainly HPC, but now they introduce quantum as well. As QuIC is now a private member of this, next to ETP for HPC or the Big Data Value and AI Association. So the idea is to build infrastructures, so to build centers, and there will be centers. The interest here is there is a procurement for those companies, so they can put the machine in live in a hybrid architecture, this architecture I was mentioning. I mean, you cannot dialogue directly with a quantum computer anyway. You need a classical interface. So that's for them a good benchmarking, a good sandbox, basically. For real projects, we start with research project, but we will go to quantum computing center of excellence, etc. And there is, so I mentioned the infrastructure, but there's also center of excellence. So there are plenty of things that are happening. Of course, I mentioned this one because it's Europe and I know it, but there are plenty of private initiative as well. Yeah. So, I mean, it's not a dream.
Be cautious of time a little bit. Is it fair, allow me that last question, is it fair to wrap it up in a way to say there's a lot happening in that entire space? We'll see many announcements in the near future, and there's a lot happening, in particular through startups and large corporate. There's a huge interest. But just to leave you the final statement, how do you feel will the entire technology develop in, say, the next 5 years or so, and how quick will this gradual progress be? Like, when will consumers see this technology be adopted broadly?
Again, I think it's very progressive, and we will have to go for a step where I mentioned those infrastructure, those quantum computer in a hybrid environment. So that will be the first steps. I'm not even sure one day we will have in the laptop this QPU I was mentioning. But do we need it? I mean, we do cloud anyway. We do everything on cloud. So this will be just on on the cloud the same way. No, I see it progressively. There will be more and more fidelity and accuracy from the computer itself, so we could do things better and better. Of course, we have to go through those projects. It's not just development today. It's still on the research stage where we have to really test and benchmark, etc. But I see it as one day, maybe not in 5 years, or it will be really a small scale in 5 years. But having this possibility as a developer to have this tool as one possibility among all the other tools. Again, it will not replace everything. It will be just a different technique. And again, it's I'm speaking for ourselves as software developers, as application software developers, especially. We need this abstraction layer, and we will work on this. And again, trust. Before that, we will work in collaboration. And this collaboration is important as well. Working, and it's not just research projects per se. It's really collaboration, doing benchmarks, etc. Until we reach a level where, no matter what is the platform, is it the superconducting, is it the photonics machine? I don't care. I have my qubits. I can use them. I can do my algorithms. That's perfect. That will take more than 5 years, but that's where the future is. And
I think we can wrap it up by saying that the time to get in touch with quantum computing is now, right? So, and
Yeah,
I
it's
think it was a
time
good
to-
step to watch this episode here, right? So thanks everybody for watching.
It's time
And
to look at it. Yeah.
thanks so much, Laure,
Super.
for being on the show.
Thank you.
That was super
And,
interesting. And talk soon again.
Thank
Bye-bye.
you for sharing all of this. Talk soon.
have a
Bye
nice
bye.
day.